created an actual bird feeder and observed the movement of the birds as well as the feed consumption in the bird feeder. The system were considered as a variable in the model includes the time, number of birds, kind of feeds, types of bird feeder, and number of holes, while the weather and the location or area of bird feeder define the environment where affect the system. The system are A. Time, which serves control on rate of flow in the model. B. The number of birds were the main variable of the model. C. Kinds of feeds, also a variable that affect in the number of bird in the model. D. Types of bird feeder were also a variable that includes the system. E. Number of holes, consider a variable that affect in the types of bird feeder in the system. The environment are A. Weather that affect the system, however, the system can't affect the environment. B. Place or location also affect the system because it matters to the availability of bird.
In this bird feeder activity, the observations are as follows. The weather is a big factor and contributor to this activity. Birds don't try to eat or come close to bird feeder due to bad weather. In rainy days, the bird feeder doesn't reduce the height of feeds, nor is the bird visible. In sunny day, the birds are visible but the amount reduced in the feeds is quite less. Second, the location is also another factor as we tried 4 locations and gladly, the last location is good because the birds, specifically pigeons, eat in the bird feeder. Third, the number and kinds of birds exist in a certain area. In our area, the birds that we saw are sparrow and pigeon. However, only pigeon try to eat in the bird feeder. Fourth, the bird feeder itself is a contributing factor which we observe that the design of a bird feeder varies directly to the attention of the birds. Like in our first model, we only use food in every hole, but sadly, it is not effective because the birds don't have landing area in the bird feeder. Next, the placing of the bird feeder in certain area if it is hung, tying in a tree, placed in a roof, and put in the ground. Based on our observations, the effective placing of the bird feeder is on the ground, monitored from time to time, and we found out that pigeons eat in the bird feeder. Next, the number of holes which we observed that the consumption in 6 holes is faster to decrease than with 4 holes, because the more holes, the more chances to big feeds in the bird feeder. These are the adjustments that we've done in the bird feeder activity. First, the bird feeder itself that we created has 3 designs. The first one has no birds try to eat because there is no place to perch. The second one is quite good because there are birds that try to eat, and so we arrived in the third model. Second, the place or the location. We had 4 locations and luckily in the 4th location there were more feeds consumed. Third, the placing of the bird feeder. We have 4 placing points and putting it on the last feed, thus there were more feeds consumed. The first location is on theater to above a tree. Second location placed at the top of the roof. Third location hung in the clothesline. Fourth location placed on the ground. Fourth, the weather affects very much in this activity. That is why our adjustment in this kind of problem is putting the bird feeder when sunny day and keep it in rainy days. We keep it on rainy days because the feeds will get wet and birds don't eat.
Summarize your data, height versus time in a table. Plot them in an XY plane too. Based on the scatter plot, decide what to use, linear data fit or polynomial data fit. Then model. In plotting the data in XY plane, we need to identify first the independent variable that change on its own and dependent variable that change with respect to the independent variable. In this activity, independent variable is x is equal to time and dependent variable is y, it is equal to height as it dependent to time. Birdfeeder with 4 holes have two datasets, the original Birdfeeder and the refilled Birdfeeder. In this table, it shows the original Birdfeeder with height of 15 cm. The start time is 12 p.m. October 11, 2020 and the end time is 7 a.m. October 13, 2020. Time elapses in R represent P, also the independent variable represent X. Height in cm H represent Y, the dependent variable. At 0R, 15 cm, then after 2 hours, 14 cm decrease or 1 cm. In after 4 hours, 13 cm decrease. In 19 hours, 9 cm left. In 22 hours, 8 cm left. In 24 hours, 7 cm left. In 32 hours, 4 cm left. And in 46, 1 cm left. It means that it is not empty, but 1 cm represent, as we observe in a battle, it can't be eaten by bird. In this table, it shows another dataset of Birdfeeder with 4 holes, which is the refill Birdfeeder. The start time is 8 a.m. October 13, 2020 and the end time is 1 p.m. October 14, 2020. Time elapsed in hours represent X, height in centimeter represent Y. At 0R, it is 15 cm. After 1 hour, 14 cm decrease. After 3 hours, 13 cm decrease. After 6 hours, 11 cm decrease or left. 8 hours, 10 cm left. After 22 hours, 5 cm left. In 24 hours, 4 cm left. In 26 hours, 3 cm left. And in 29 hours, 1 cm left. Same as in original Birdfeeder. The X and Y plane of Birdfeeder with 4 holes at original Birdfeeder shows that data points in the X and Y plane decreasing. The highest point is 0.15 and the lowest point is 1.46. As we can see, it is in decreasing, where the points have trend into decreasing line. The X and Y plane of refilled Birdfeeder with 4 holes, same as in original Birdfeeder, the data or the trend of this plane is decreasing. The highest point is 0.15 and the lowest point is 1.29. A table of values on X and Y plane of Birdfeeder with 4 holes in both original and refilled one, it shows the comparison and contrast among two data sets. The comparison of two data sets are the points are decreasing and expressed in indirect variation because as time increases, the consumption decreases. The contrast among the two datasets, the refilled Birdfeeder, show the consumption is faster than the original one. The original one take days to empty due to reason that the bird observed the Birdfeeder if it's safe for them. That is why it is not easily eaten, the feeds in the Birdfeeder. On the other hand, the refilled Birdfeeder is easily to consume and empty because they know that it is safe and adjust to the setting. In data from 4 holes from the original Birdfeeder, as we can see in the scatter plot, it shows that the data point is decreasing, same in the linear values and polynomial values. In data from 4 holes, the refilled Birdfeeder, same as the original Birdfeeder, the data, which is the trend line, decreases in both polynomial and the linear values. In this data, it shows the original Birdfeeder in 4 holes and the refilled Birdfeeder in 4 holes. In original Birdfeeder in 4 holes, the linear curve fitting is y is equal to negative 0.3116x plus 14.539. So the regression is equal to 0.29849. In polynomial curve fitting, the y is equal to 0.0013x squared minus 0.365x
plus 14.822. The regression is 0.9887. On the other side, in refilled bird feeder in 4 holes, the linear curve fitting, the equation is y is equal to negative 0.4426x plus 14.297, and the regression is equal to 0.9907. In polynomial curve fitting, y is equal to 0.0026x squared minus 0.516x plus 14.497. The regression is equal to 0.9917. As shown in this equation, where the original and the refilled bird feeder being compared through scatter plot, we can say that the polynomial curve fitting can be best fit in this model. The polynomial equation in both data set are in beta regression because the correlation value for both data set in polynomial regression are about 0.9887 and 0.9917, which is closer to 1. Then the linear correlation value of the both data sets are about 0.9849 and 0.9907. We uses the regression value since the graph of both data sets show closer match to the dots in the scatter plot on both linear and polynomial curve fitting. In the bird feeder with 6 holes, it has also 2 datasets, the original bird feeder and the refilled bird feeder. In this table, it shows the original bird feeder with height of 15 cm, same as on 4 holes. The start time is 12 p.m. October 11, 2020, and the end time is 7 a.m. October 13, 2020. Time elapsed in hours represent x, height in centimeter represent y. At 0 hour, 15 cm. At 2 hours, 14 cm. After 4 hours, 12 cm. Then after 19 hours, 18 cm. In 22 hours, 6 cm left or decrease. After 24 hours, 5 cm decrease or left. In 27 hours, 3 cm left. And in 32 hours, 1 cm left. In refilled bird feeder with 6 holes, the start time is 8 a.m. October 13, 2020, and the end time is 1 p.m. October 14, 2020. Time elapsed in hours represent x, and height in centimeter represent y. At 0 hour, 15 cm. After 1 hour, 14 cm decreases or left. Then after 3 hours, 12 cm. Then after 6 hours, 10 cm left or decrease. After 8 hours, 9 cm left or decrease. In 22 hours, 4 cm left. Then after 24 hours, 3 cm left. And in 26 hours, 1 cm left. In x and y plane, a bird feeder at 4 holes in the original bird feeder, same as in the 4 holes, the x and y plane, the points are decreases. The highest point is 0, 15, and the lowest point is 1, 32. In x and y plane of bird feeder at 6 holes in refilled bird feeder, it shows the line the points decreases, which is the highest is 0, 15, and the lowest point is 1, 26. A table of values on x and y plane of a bird feeder with 6 holes in both original and refilled one. It shows the comparison and the contrast among 2 data sets, also compared to the bird feeder with 4 holes. This bird feeder with 6 holes is easily to empty due to reason that the number of holes varies directly to the consumption of bird feeders. The comparison of 2 data sets are the points are decreasing and expressed in indirect variation because as time increases, the consumption decreases. The contrast among 2 data sets, the refilled bird feeder show the consumption is faster than the original one. The original one takes days to empty due to reason that the bird observes the bird feeder if it is safe for them. It is why it's not easily eaten the feeds in the bird feeder. On the other hand, the refilled bird feeder easily to consume and empty because they know that it is safe and adjust to the setting. In data from 4 holes from original bird feeder, the polynomial values and the linear values shows in the scatter plot have in the same line or trend line, and it is in decreasing order. In data from 6 holes in the refilled bird feeder, the linear values and polynomial values is decreasing. Also, they have a gap in the linear value and polynomial values. The set or the data intercept is present in this scatter plot data. This is the model in the bird feeder with 6 holes. In original bird feeder in 6 holes, the linear curve fitting is the equation is y is equal to negative 0.4133x plus 14.716, whereas the regression is 0.9827. The polynomial curve fitting of the equation in the original bird feeder as y is equal to negative 0.0037x squared minus 0.3028x plus 14.414, and the regression is 0.987. In the refilled bird feeder in 6 holes, the linear curve fitting, the equation is y is equal to negative 0.763x plus 13.858, and the regression is equal to 0.9747. The polynomial curve fitting, the y is equal to 0.102x squared minus 0.461x plus 14.539, and the regression is 0.98. As shown in this equation, where the original and refilled bird feeder being compared through a scatter plot, it can say that the polynomial curve fitting can be best fit in this model. The polynomial equation in both datasets are in better regression because the correlation value for both dataset and polynomial regression are about 0.987 and 0.9854, which is closer to 1 than the linear correlation value of both datasets are about 0.9827 and 0.9747. We uses the regression value since the graph of both datasets shows closer match to the dots in the scatter plot on both linear and polynomial curve fitting.
For number 4, you are going to show the predictability of your model by using it to calculate values and comparing them to actual values. So for bird feeder with 4 holes, we're going to get first the actual values of the original bird feeder before the refilled one using the linear curve fitting and the polynomial curve fitting. For the linear curve fitting, we have the equation c of phi is equal to negative 0.31165 plus 14.539. And for the polynomial curve fitting, we have the equation c of phi is equal to 0.001395 squared minus 0.3655 plus 14.822. Using the linear curve fitting, to get the actual values of the original bird feeder, we're going to use the equations mentioned a while ago. C sub phi is equal to negative 0.31165 plus 14.539, wherein the values of phi is equal to 24 hours, and then by substitution we have C sub 24 is equal to negative 0.31165 times 24 plus 14.539, that give us C sub 24 is equal to 7.05844. Using the linear curve fitting, to get the actual values of the refilled bird feeder, we're going to use the equation C sub phi is equal to negative 0.44265 plus 14.297, wherein the value of phi is equal to 24 hours. And then by substitution, we have C sub 24 is equal to negative 0.4426 times 24 plus 14.297, having the result of C sub 24 is equal to 3.6746. And using the polynomial curve fitting, we're going to use the equation C sub phi is equal to 0.0026 phi squared minus 0.5165 plus 14.497, wherein the value of phi is equal to 24 hours. And then by substitution, we have C sub 24 is equal to 0.0026 times 24 squared minus 0.516 times 24 plus 14.497, having the result of C sub 24 is equal to 3.6106. So meaning, the actual values of the refilled bird feeder is 4 cm at 24 hours. In bird feeder with 4 holes, the calculated values and the actual values has the same result as C sub phi is equal to 24 hours in two datasets. It means that the equation is correct, and using polynomial equation as chosen model is absolutely correct. In the case of linear equation, as we compare the calculated values and the actual values, the result has the same value, which means that the linear equation can be used in this dataset. As we compare the calculated values of two datasets, though they differ in decimals, but if we are going to round off it, it will result to actual values. In Birdfeeder with 6 holes, the same method we use in Birdfeeder with 4 holes, we're going to get the actual values of the original Birdfeeder and the refilled Birdfeeder using the linear curve fitting and the polynomial curve fitting. And the linear curve fitting equation of the original Birdfeeder is C sub phi is equal to negative 0.41335 plus 14.716, and the polynomial curve fitting equation is C sub phi is equal to negative 0.00375 squared minus 0.30285 plus 14.414. Using the linear curve fitting to get the actual values of the original Birdfeeder, we have to use the equation C sub phi is equal to negative 0.41335 plus 14.716, wherein the value of phi is equal to 24 hours. And then by substitution, we have C sub 24 is equal to negative 0.4133 times 24 plus 14.76, having the result of C sub 24 is equal to 4.7968. Using the polynomial curve fitting to get the actual values of the original Birdfeeder, we are going to use the equation C sub phi is equal to negative 0.00375 squared minus 0.30285 plus 14.414, wherein the value of phi is 24 hours. And then by substitution, we have C sub 24 is equal to negative 0.0037 times 24 squared minus 0.3028 times 24 plus 14.414, having the result of C sub 24 is equal to 5.0156. So meaning, the actual value is 5 cm at 24 hours. For a refilled Birdfeeder, to get the actual values, we're going to use the linear curve fitting equation C sub phi is equal to negative 0.47635 plus 13.858, wherein the value of phi is equal to 24 hours. And then by substitution, we have C sub 24 is equal to negative 0.4763 times 24 plus 13.858, having the result of C sub 24 is equal to 2.4268. And using the polynomial equation, we have C sub phi is equal to 0.01025 squared minus 0.74615 plus 14.539, wherein the value of phi is equal to 24 hours. And then by substitution, we have C sub 24 is equal to 0.0102 times 24 squared minus 0.7461 times 24 plus 14.539, having the result of C sub 24 is equal to 2.5078. So meaning, the actual values of the refilled Birdfeeder is 3 cm at 24 hours. In Birdfeeder with 6 holes, the calculated values and the actual values has the same result as C sub phi is equal to 24 hours in two datasets using polynomial equation. It means that the equation is correct, and using polynomial equation as chosen model is absolutely correct. In the case of linear equation, the result in refilled Birdfeeder is not equal to the actual value even when we round off it. It means that in this model, polynomial curve fitting can only be used due to reason that the actual and calculated values are correct in two datasets.
Fifth conclusion. As we conduct an activity in Birdfeeder, we observe the consumptions of the height of feeds in the Birdfeeder. As time goes by, we feel the true importance of modeling. In this activity, curve fittings gives importance in creating the model. Curve fitting examine the relationship of independent variable, which in Birdfeeder's activity is the time, and dependent variable, which is the height of the Birdfeeder. Identifying the best fit between the linear curve fitting and polynomial curve fitting is best analyzed. In our data, where scattered plot used as the basis of making a model, we use the regressions of both Birdfeeder model, which consists of two data set Regressions is used to find the best fit line or the regressions equation that can be used to make prediction. As we make predictions through solving the actual and calculate values, we found out that the equations that we used is correct, which means that we are in the right track of modeling.